Question number 43. The average molecular speed of H2 gas at 80 degrees is lower. So not it's lower, it should be higher because temperature is higher than of N2 at 40 degrees Celsius. The average molecular speed is directly proportional to the square root of the temperature and inversely proportional to the mass, square root of mass. First, identify the difference between average molecular speed, okay, average speed, and let's use the board for an example, okay. I'll use the board for this. So the average speed, average molecular speed is when you have like, let's say 3 molecules in a system like this, okay. Then this one have C1, C2, C3 velocity. Average means you get C1, C2, C3 and you divide by the number of molecules, which is 3 here for an example. Then root mean square velocity means you get the square of this. This is normally called C bar. This is C squared bar root. Okay, so you get the square of these and you divide by the number of molecules, then you get the root. Okay, so here they are talking about average molecular speed, not the root mean square. Don't forget. And if you remember about this relationship where we had like from the ideal gas equation, we have PV is equal to nRT. From the kinetic molecular theory, we have PV is equal to 1/3 mnc squared bar. It is the square velocity, this one, not the root, just the square velocity. Square. Then this mn means this is mass of a molecule m and the number of molecules, which gives the mass of the gas, which also can be obtained by n into capital M. Because simple m means mass of a molecule, n means number of molecules. So mass of a molecule multiplied by number of molecules will give the mass of the gas in the system, like this. This also can be obtained by the number of moles molecule multiplied by the molecular weight. So when you equalize this, you will have nRT is equal to 1/3 n capital M C squared bar. So n to n can be cancelled out. So you will realize C squared bar is equal to 3RT over M when you get the root. So this is okay. So here you will see the root mean square is proportional to root T over root M. Okay. This is proportional to this, not the average molecular speed. Average molecular speed is just proportional to the temperature. Like if you have higher temperature, there will be higher speed, and if you have lower temperature, there will be lower speed. And it is not depending upon the root of the temperature. Okay. If this is root mean square, then it is correct. You see? So when you go to that particular question, so you see here the average molecular speed directly proportional to square root of the temperature. So we see it is not the average molecular speed. So typically this is the root mean square. They have not defined it really well. Okay, and even here the average molecular speed at H2 gas is lower, not low, it is high, because high it mainly depends upon the temperature. Okay, both statements are wrong. This is correct if this is given as the root mean square velocity. Okay, so both are wrong. That is why the answer is